In this video, I'll be solving the 7th problem of 2025 AIME session 1. So there are 12 letters A, B, C, D until L are randomly grouped into 6 pairs of letters. The 2 letters in each pair are placed next to each other in alphabetical order to form the 6-letter words. And then these six words are listed alphabetically. So they have also given an example like A, B, C, J, D, G, E, K, F, L and H, I. So we need to find that the probability the last word contains G. So they're saying like the last word is containing G. So that means, so we are having like 5 words. 1, 2, 3, 4, 5, 6. Yeah, 6 words. And then last word is containing G. So G can be in the first place of the last word, or G can also be in the second place of the last word. So that can be like one plan to like use this 2-case idea. Now second thing is, now like if G is, so that means like all the first letters of the before words must be less than G. So let's take like 2 different sets here, like before proceeding. So we can consider, let's say omega is a set containing the letters before G, and sigma is the letters containing A to F, and omega is the set containing the letters after G. So now like if, so basically after pairing each unordered pair, so we write the smaller letter first, and then the last word in the alphabetical list is the pair whose first letter is largest. So that is the case, like, so that's how like we're breaking our cases. So our G can be either first letter of the last word, or G can also be second letter of the last word. So our case 1 is G is first letter of last word. So if G is first letter of last word, so we are having 1, 2, 3, 4, 5, 6. So G is first letter of last word. So if G is first letter, so that means it can only be paired with one of the letter from omega, because otherwise like we can see like all the letters in the sigma are less than this G, so they can't be paired with. So first thing is, so it is paired with one of the letters of the set omega. Now every letter after G in the alphabet, like all of this, so every letter like after G in this in the alphabets cannot be the first letter. So that means the 6 first letters are G together with 5 letters from this sigma. So that means first letters are fixed, A, B, C, D, E. So because they should be in the increasing order, so the first letters are also fixed. So now regarding the second letter, like we don't have any restriction for the second letter, but like it should be less than that particular thing. So so basically the first 6 letters are G together with this letters of sigma. Now consequently, like exactly one pair from this sigma and the other 4 sigma letters pairs pair with this 4 remaining omega letters. So basically it can be A, B, C, D, E, or it can be B, C, D, E, F, or it can be A, C, D, E, F. So it can be like anything. So first we can choose G's partner from this omega. So that can be done like, so G's partner if we take from omega, so that would be, so out of this 5 it can be anything, so 5 choices are there. So 5 choices are there for this omega. Now we can choose which unordered pair from these 2 letters form this sigma pair. So basically we are having 6 letters here, but like we are having only 5 positions here. So that means like one like pair must be sigma sigma pair. That means sigma letter pair should be there. So like we can also do that thing first. So one sigma sigma pair would be 6 choose 2, that is 15 choices. Now we are left with, so we have used one letter here, we have used 2 letters here. So that means we are left with 4 letters from sigma and 4 letters from omega. 4 letters from sigma and 4 letters from omega are left. Now like these two can be paired. Like for example, suppose like if we are pairing D and E. So let's say if we are pairing D and E, so that means the remaining must be paired, like A, B, C, F must be paired with the letters of either the letters that are remaining, because like we are using only one letter to be paired with G, so the remaining will get paired with them. So for example, like A, C, D, E are left in the first and H, I, J, K are left. Now these will be paired. Now these can be paired in, like if we fix this, suppose above order, if we are fixing this, that means we just need to find number of ways of rearranging H, I, J, K, and that can be done in 4 factorial ways. So therefore in this first case, so there will be 5 choices to choose the pair for G, and there will be 6 choose 2 ways to choose that single sigma sigma pair, and we'll be having like 4 factorial ways to like bijectively match the remaining 4 letters of sigma or 4 letters of omega. So therefore in our first case we'll be having 5 into 6 choose 2, so that is 2 factorial into 4 factorial into 4 factorial. So that is 5 into 120 by 2, which is 5 into 720 by 2, which is 5 into 360, and that's nothing but 180. So there will be 118, so 1800 pairs in the first case. So that's about our case 1, like where G is the first letter of the last word. Now like coming to the second case. So our second case is, so case 2 is G is second letter of last word. G is second letter of last word. Now if G is second letter of last word, let me write once again what is sigma. Sigma is like the letters before G, so A, B, C, D, E, F, and omega is the letters after G, that is H, I, J, K, L. So now we are having like 6, so 1, 2, 3, 4, 5, 6. So this is like F and G. So it should be F, because otherwise like there isn't any other digit like before. So the first maximal first letter must be F, because all the other letters because like in the set of first letters is exactly A, B, C, D, E, F. So even if we start with A, B, C, D, E, F, so we'll be, I mean that's exactly fitting. So basically the 6 of these letters, like 6 first letters in this pair must be from sigma, because like we're only having 6 there, and we're having 6 pairs here, and G should be after that letter. So that means like we are forced to pair this F to G, so there is only one pair. So now like we're having A, B, C, D, E. Now these has to be paired with H, J, K, L. So these have to be paired along with the first letters which are already fixed. So that can be done in 5 factorial ways. So the second case is like pretty much simple when compared to first case. So therefore the total favorable pairings would be 1800 plus 120, which is 1920. Now we need to find total pairings of 12 letters into unordered pairs. So total pairings of 12 letters into unordered pairs. So this is something like similar to, like for example, if we are having like 2 and distinct objects, and suppose like these 2 and distinct objects, if we have to divide them into n unordered pairs, so then So first we can start like with permuting them. So start with 2n factorial permutations of all objects. Now here like order inside each pair doesn't matter. So for each pair like we have to divide by 2. So we are having like n pairs. So basically we are dividing it n times. Now dividing by 2 by and so we are dividing by 2 n times, and then the order of these pairs, these n pairs doesn't matter. So therefore like we also have to divide it. Since it's a unnamed grouping, we have to divide it by n factorial. So that means this is nothing but 2n factorial by 2 to the power n into n factorial. And this we commonly we use this notation, number of ways to divide 2n distinct objects into n unordered pairs. So this is also called this double factorial notation. Like few books use this double factorial notation here. So this is 2n minus 1 double factorial. That is, the general form is something like this: 2n factorial whole divided by 2n into n factorial. So basically here we'll be like just multiplying. So if we cancel out all the 2's, all the even numbers from this 2n's, we'll be left only with odd numbers. So that is the common reason why we'll be using this double factorial notation. So 5 into 3 into 1. So it's just product of all odd numbers. So here like we're having 12 factorial. So 12 double factorial, this would be, not 12. This would be 12 minus 1 double factorial. So that is nothing but 11 into 9 into 7 into 5 into 3 into 1. So therefore our required probability would be 1920 by 11 into 9 into 7 into 5 into 3 into 1. So we have like 5 here. So if we divide, like we can see the number is divisible by 3, number is divisible by 5 as well. So that means it is divisible by 15. So in fact like it's also divisible by 7 because no, it's not divisible by 7. So it's divisible by 5 and 3. So 15, like when we divide with 1920, 15 ones 15, 42. So we are left with 128. So 128 by, so 63 into 11. So 63 into 11 would be 693. So this is our required probability, and this is m by n, and we can't reduce it further into like simple fractions. So this would be, so m plus n would be, and since 128 and 693 are relatively prime, we can add. So 128 plus 693, so that is nothing but 821. So therefore answer for this question would be 821. So that's it for this video. We'll meet in the next video.